Try this again. Take two. So this is kites, and let's put a kite right here and see what a kite is, and we'll see. You don't like them already? You don't like them? Why not?
Can you rotate it? Because it's kind of bothering me.
What's wrong with it?
Like, move it the right way up.
What? You want this side over here?
No, like the right way up.
Oh, like a
Please?
Oh my goodness. All right, so we'll rotate 90.
Yeah, like that.
Like that?
Yeah.
Okay. You guys are so picky.
There.
Is that better? All right, there you go. How's that? All right, so what in the world is a kite? Well, first of all, is a kite a parallelogram?
Yeah.
No, because look at this. The opposite sides have to be parallel to each other. Does this side right here look parallel to that side right there? It does look perpendicular, and it is. Okay, but does this side right here look perpendicular or parallel to this? No. And remember, they also have to be equal to each other too, right? To be a parallelogram, they're definitely, I mean, some people might look at this and say, yeah, it looks parallel, all right? But they're definitely not equal to each other. So would you agree the opposite sides are not equal to each other? So it's definitely not a parallelogram, is it? It's not a trapezoid either, because we don't really have anything that's parallel to each other here, do we? On a trapezoid, at least you have one pair of parallel sides parallel. On a kite, you don't have any sides parallel to each other. But you do have some things that kind of look. Okay, one thing you've already said, right? That this definitely looks like a right angle, and it is. Okay, so what do we call these things? What is this line right here and this line right here called? Well, they're perpendicular, but it's not what they're called. The line itself is called something. What is it? No, it's not a mid-segment because it's not connecting midpoints or anything like that. What is it? It's a diagonal, right? Okay, it's a diagonal, right? We've done diagonals of parallelograms. We've done diagonals of like rectangles and squares. We've done diagonals of trapezoids, right? Well, we're doing a diagonal of a kite. So what do you think might be true about the diagonals of a kite? They're perpendicular. You might want to jot that down somewhere. The diagonals of a kite are perpendicular. And that's actually a theorem. It's on the top of page 439. And I don't care what the number is. I just care that you know what it means. Okay, so the diagonals of a kite are perpendicular. All right, so that's a good thing. What else do you think looks like they might be true about this? What do you think, Kate? You want to label this?
Yeah.
A, B, C, D. And we'll call that X. Just be different.
Is dx equal to xb? No, dx is equal to xb. Oh, you did?
Let me think about that.
Or is
I hadn't thought about the diagonals.
Because it really looks like
I don't think we have a
perpendicular,
theorem that says
be the
that.
same?
Well, not just because they're perpendicular doesn't mean they're the same.
AC would equal BC, and then dx would equal xb.
It looks like it's true. It possibly is true. Now, I'll tell you this: it's not one of our theorems, but it doesn't mean it's not true. So it does look like this one is being bisected. Now, what about this longer one right here?
Yes.
That doesn't look like it's being bisected there, does it? The longer one? AX and XC? No way. XC is way longer than AX. Would you agree?
Oh.
Okay. DX and BX, yeah, they possibly could be equal to each other. And let's see, and they...
AB and AD.
I'm trying to think of why they would be equal to each other. Let me think about this for a minute as far as that. I hadn't even thought about that. But, Justin, what else? What do you see? Okay, that would be a good idea to see if they actually are, okay? But let's just talk about the definition of a kite. You give the definition of a kite? Let me find it. Oh, there it is. It says it's quadrilateral with exactly two pairs of consecutive congruent sides. What does consecutive mean? Consecutive means the ones next to each other, one after another, right? So if I say the Phillies are going to win 5 consecutive World Series starting this year, okay, so that means what? One after another, after another, after another. Follow me on that? Okay, so it says it has exactly two pair of, let me see, quadrilateral with exactly two pair of consecutive congruent sides. So what do you think? It's probably that one, and what else? AB. What does?
625.
625?
On page 439.
Then its diagonals are perpendicular.
But then
625.
it shows, see, the little red lines.
No, it doesn't. It's still not showing that dx and bx are equal to each other. I mean, I'm not saying that's not true, but I have to think about it for a minute. We're just going by definition right now, okay? Yes. It's on the bottom. It's on the bottom of 438. Okay. I'm not going to write out the whole definition. I'm going to mark it on my picture though. Okay. Here's basically the definition of a kite. It's a quadrilateral with exactly two pairs of consecutive. How do they say it again? Two pairs of consecutive congruent sides. That's what I was going to say. Two pairs of consecutive congruent sides. So this one and this one are equal to each other. There's another pair. What do you think the other pair are? Give me letters. I got letters here. DC and BC. Right. So those two. So if I have a situation like that, then I have a kite. You got it? So that's the definition, is that you have two pairs of consecutive congruent sides. Got it? So these are next to each other, they're congruent. These are next to each other, they're congruent. So congruent sides. So that must be a kite, because that's the definition of a kite, Sarah.
Could that mean that like angle A is congruent?
All right, well, let's talk about that. All right. Here's a theorem. This is actually a theorem. Now, one of our other theorems, right? So definition is about the sides. The first theorem, we've already talked about that the diagonals are what? Perpendicular. Okay, that's this theorem right here. Okay, then you have another theorem. Okay, and Sarah kind of alluded to it. If you look at this, that it says exactly one pair of opposite angles is congruent. Exactly one pair. Well, it depends, right? And I'll tell you which ones are. First of all, does this angle, now don't mark this, okay? Because I'm going to erase this in a second. Does this angle right here look congruent to this angle right here? No, obviously not. That looks quite a bit wider, doesn't it, than that one right there? So that's why I told you not to mark it. So remember, the theorem says you have exactly one pair of opposite angles. Are they your pair of opposite angles? No, they're not. Which ones are your pairs of opposite angles? This one right here and this one right here. Okay? So angle D, we'll call it angle D, or ADC, right? Or angle D and angle B would equal each other. Okay? Now, how do you know which ones are equal to each other? Just by looking at it and telling? No, it's because look at this angle right here. It's between these two sides. It's between the two non-equal sides. You follow me? So what about this angle right here? This would be between the two equal sides, right? So it's not between the two equal sides. It's between the two non-equal sides. Does that make sense? Okay. So by definition, we know all that's true. And then by a theorem, we know that this angle right here is equal to this angle right here. All right? And we know that angle A, this big angle A right here, and this little angle C down here, we know that they are not equal to each other, because this theorem says that it has exactly one pair of opposite congruent angles. I guess that's how they say it. We good with that? Okay. Let me see what else. Let's think about this for a second. Because Caitlin brought up a point.
So they are?
Caitlin brought up a point that I really need to investigate here, because I'm not really sure. I can't think if this is true or not, but it sure looks like it would be true, that dx and bx would equal each other. Wouldn't you agree?
Yeah.
I mean, doesn't it look like that's true? So, where is that? 4b, okay. Right, so what's that? BT is fine. Well, that's not really what it, I don't think that's what it's saying, Allie. It's not saying that BT and DT are equal to each other.
No.
Well, that's what I'm going to try to do. Are these triangles congruent to each other?
Because side angle side, and then
Wait,
that's the
well, is it side angle side?
Yeah. Because
No,
no,
it's not. No, it's not side angle side. Because I don't have a in between angle. I don't know that this angle and this angle.
Side.
Yeah, but but the angle's not between the two equal sides, right? If we say side, would you say side angle side? You can't say side angle side with this information. There is no angle side side. Where's the other angle?
The right angle.
That's one angle. Are you talking about? Oh, we must be talking about different. Okay, I'm sorry. Wait. Let me think first. Okay, I got everybody chirping at me. Let me think. I was looking at two different triangles. I was looking at triangle ADX and ABX. You're looking at ADC, aren't you? Okay, that was my fault. Okay, so let's get rid of this and get rid of this. So, the two big triangles, ADC and ABC, they are congruent to each other, right? Because by definition, these two, and then AC equals AC because they're reflexive. So yeah, so those two big triangles are congruent to each other. So now let's mark some stuff. Since I know that triangle ADC and ABC are congruent to each other, then I can say a few things, can't I? I can say that this angle and this angle are equal to each other, right? Because they're corresponding parts, right? CPCTC, right? They're corresponding parts of those congruent triangles. What else must be equal because of those triangles being congruent? These two down here, correct? All right, so these two must be equal to each other as well. All right, so this isn't really a theorem, but we could kind of make it a theorem, I guess. All right, I'm surprised that they don't have this as a theorem. So we do know that this angle is equal to this angle. Now take a look. Now let's look at this triangle right here. Because my whole thing was to try to find out if dx and bx are equal to each other. So now we have a side, an angle, and we've got this side, don't we? Yep, you don't even need the right angle, to tell you the truth, though, do you? But because watch this. So I've got a side, an angle, and a side. So this triangle, this little triangle, ADX, is congruent to this triangle, ABX, because of side angle side. Now, if these two are congruent to each other, then this angle right here is equal to this angle right here, right? Would you agree? And if they're right next to each other and they're supplementary, if those two angles are supplementary, they both have to be what? 90 degrees. So we kind of just proved that theorem about this being perpendicular, right, by using congruent triangles. Did that make any sense? So that's exactly right. So if I have this triangle right here congruent to this triangle right here, then dx must equal bx because of corresponding parts, CPCTC. And they don't have that written down anywhere, do they?
Well,
About the kite. But we figured it out on our own. So we kind of came up with our own theorem. Wasn't that fun? Yeah, I think so. So that is true, that dx and bx are equal to each other. And why is it? Well, we went through the whole deal, all right? We showed that these two, triangles on the side are congruent to each other, which means that these angles are equal because of corresponding parts. If these angles are equal, side angle side, this triangle right here and this triangle right here. Same thing here. Of course, this angle right here and this angle right here would be equal to each other as well, right? These two, right? These two would be congruent triangles as well, wouldn't they? Because look, I've got a side, side, and what else? I got this side right here. I guess we could put 4 marks there. Okay? So everything that you probably thought was true is true. But we just proved it, though. We didn't just look at it and say, well, it sure looks like it. We didn't do that. We went through and we showed exactly why all that stuff was equal. Does it make sense? All right. So again, how do you know which angles are equal to each other in a kite? They're the ones between the two different sides. You get it? Here are the two different length sides. This is the angle between, so that angle and this angle are equal. Look at this big angle A right here. Is that going to equal big angle C right here? No, because it's between the two equal sides. You get it? All right, so they're not equal, but these are equal. And I think we covered it. Well, if you move point A over to the left, then AB wouldn't equal AD, and then it wouldn't be a kite, right? So if I took A and I scooched it over a little bit, that's going to make this extend a little bit further, isn't it? You follow me? And this is going to be shorter. They're not going to be equal, then it's not a kite. All right, so we couldn't scooch it over. If we did, it wouldn't be a kite. Any other questions? I think we covered everything here, didn't we? Yes, ma'am.
So basically, all you really need to know is that the two top are congruent and the two bottom.
Like AD and AB,
and then you
right?
can prove that everything else is congruent too. If the lines
Yeah,
are congruent,
exactly right.
then they're not kite.
Yeah, because we could have proven that this big angle D and this big angle B are equal to each other, right? Because we had side, 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 right? And you could say angle D and angle B are equal because of corresponding parts. Absolutely. So all you needed to know was the definition of a kite, and you can prove all that stuff is true. Absolutely. Yes, sir. Yes, this big angle A, B, C, and D do add up to 360 degrees. That's right. All right. Anything else on this? I think we covered it pretty good on that, don't you? Now look at this. It says,
Can you do examples?
yeah, let's do it. We'll do an example. Yeah, let's do an example. Which one? 4A, 4B? On 440? Example 4. Okay. Let's scooch that out of the way. Let's get my kite back up here.
What number?
Let's squeeze it in a little bit. Example 4, like number 6 and 7. Is that what you're saying?
Yeah, number 6.
Like number 6, right? Okay. All right, let's take a look at that. Like, it's number 6. Oops, come on. Oh, this is not. I thought that would squish it in. Well, that's all right. It's good enough. Oh, maybe I could do this. Oh, that's what I want to do. Yeah, I want to fatten it up a little bit. There we go. And let's make it a little bit bigger. No, it's perfect the way it is for number 6. All right, so let's take a look. Number 6 says you got a 3 right here, and you have a 4 right here, and you have to find AB, which is right here. Oh, that's easy. You don't see it? Yeah, you can do it in your head now, because we learned, what did we learn the other day? 3, 4, 5, didn't we? Because, look, if this is a kite, what's true about the diagonals of a kite? They're perpendicular. So if this is 3, this is 4, this is the hypotenuse to this right triangle. You could do Pythagorean Theorem if you wanted to, but we had a little shortcut, didn't we? 3, 4, what? 5. As simple as that. Anything else?
What if it was like,
Okay.
instead of 3, 4, 5, it was like 7?
Okay, that's a good question. Like,
Look
look at page 439 at the bottom. It says check your progress, 4A and 4B. Let's do that. Let's get rid of that and put this on here. Pyth, pith, and then ag, A-G, Orean, O-R-E-A-N.
I got Pyth.
Pith. Come on, I helped you.
P1.
Pith, then ag, Orean, O-R-E-A-N. Just spell it out. Phonics, right? Did you guys learn phonics?
No, but you should see a phonics book my sister brings home. She has to learn.
Yeah, Tollix really uses phonics.
The note cards are like this thick.
And then T is in here. Okay, what do they tell you? They say that angle BAD is 38 degrees. BAD, right there. Let's change colors. Make it a little thicker. This is 38 degrees. And then angle BCD is 50. BCD, that's this whole big angle right there, is 50 degrees. Find angle ADC. So ADC is this thing right there. All right. Well, what did we just say about the diagonals? What did we figure out that the diagonals do to the opposite angles? Okay, they bisect them, right, or divide it in half, I guess. So if this whole thing is 50, what's this little one? 25, and then this little one is 25. Agreed? If this is 38, talk to me.
Wait,
That's 38.
It's BAD.
BAD. Sorry about that.
So
Gotcha.
it would be 17, right?
It'd be 19, wouldn't it? Yeah, sorry about that. Thanks for pointing that out. So that whole thing is 38 degrees. So what's each one of these? That'd be 19. So that'd be 19. That would be 19. All right, and we want to find this one right here. So that's pretty much it, right? I got this triangle right here. This is 19. This is 25. So how do we find that? Just go 180 what? Minus 19 and 25. What's that? 44? Is that right? Because 20 is close to 19, right? 20 and 25 is what? 45. Take one away, and that's 44. Am I doing that right? You guys are silent. I kind of doubt myself when you guys are quiet like that. So that angle right there would be 136 degrees. Does that make sense? Yep, that's the answer. All right. I'll keep all that stuff on here. Let's just do the other one in another color here. We'll go blue. It says BT is 5, so that is 5. and then TC is 8. So that's 8. Find CD, all right, would be this right here. So we're trying to find CD. But CD is the same as what? BC, all right? So really, let's just find BC. Wouldn't you agree? All right. So it's kind of like the other one, except it's not 3, 4, 5. So what do we know about this angle right here? It's 90 degrees because diagonals of a kite are perpendicular. So if this is 5 and this is 8, how do we find BC right there? We use the what? Pythagorean Theorem. Let's spell it since we had some problems with that. Pythagorean. Pythagorean. Named after who?
Pytho.
Pythagoras. Oops. Why did I start with... Yeah, she's not in here. Pythagoras. Some old guy way back in the day. I don't know. I'm sure he was young at one point, but yeah. So anyways, some old guy Pythagoras. Look him up. He's actually a pretty interesting character. He didn't just come up with this theorem. That's not the only... He actually listen to this. He didn't even come up with this theorem. Why in the world would they give him the name if he didn't even come up with this theorem? He was actually... I know very little about Pythagoras, but I do know this, that he's actually given the name Pythagorean Theorem because he came up with a nice, concise, easy to understand proof of this a squared plus b squared equals c squared. Yeah, right. That's why I'm surprised nobody's remembering what I'm saying. So anyway, so here we go. How do we do this? It's 5 squared plus what? 8 squared equals whatever. We'll call it c squared. And then you just do this. That's 25 and 64. And what's that? 89. Is that right? 89 equals c squared, though, right? And what do you do to get c? Square root both sides, and that's your answer, the square root of 89. And just keep it the square root of 89. There's no reason really to put that into a decimal, but that's okay. Just in your head, though, what do you think? It's what point? It's around what? It's between 9 and 10, isn't it? Because what's a little smaller than 89 that you can take the square root of? 81, right? And which is 9, right? The square root of 81 is 9. Square root of 100 is 10, right? So it's between 9 and 10. All right? So that's kind of a nice way to figure out what it is. All right, but if you just keep it square root of 89, I'm perfectly fine. All right, does that make sense? So that should help you out a little bit. That should help you with the homework too, right? Because that's the kind of stuff you're going to do on there. All right? Lots to know about kites. Okay, that's good. Let's, what's that, the homework?
Just do the homework from last
Yeah, just the stuff on the kites that you may not have been able to do last night. I'll just let you finish that up tonight, okay? And we'll take the quiz on Monday. I know some of you guys are going to be gone. You can take it on Tuesday then, okay? The rest of us will take it on Monday. Well, not us, because I'm not taking it. So no, I'll collect it on Monday, all right? Finish the homework from yesterday that I assigned, and then I'll collect it on Monday. And if you're not here Monday, I'll collect it Tuesday, all right?